Hey, Brad Bingham here with Bingham Built Bikes. We're just going to take a few minutes and show you how a tube set makes its way into the frame fixture. So today I'm going to be tack welding this gravel grinder. Here's the drawing. We won't get into detail about that, but I will take you into detail just about how the tubes go in the jig. So the tube set is here and it's clean. It's come out of the ultrasonic cleaner, which has a hot soap solution tub and a hot clean water tub, and they spend about 20 to 30 minutes in each, and then they come out here and typically air dry, and that's what these tubes have done. And they're ready to go into the Anvil Supermaster frame jig. So step one is to get the dropouts into what we call a dummy axle. And my dropouts are of my design. So they're manufactured for me by Oaks Manufacturing in Fort Collins, Colorado. And they're a 12 millimeter through axle design that have their own specific holders, which these dummy axles I machined here to be compatible. So step one is the dropouts have a steel heatsink that gets plugged in and bolted in. So this is the non-drive side. It's like that. Groove snaps in. Little back purge puck. Voila. And that'll get tightened down in a moment. And then the drive side has two heatsink parts that go in similar fashion. A couple of bolts. And you'll see I'm wearing some nitrile gloves that are just fresh out of the box, so I feel comfortable touching some of these titanium components before they get welded. I still try to keep it to a minimum because they get a little bit dirty through the process as well, just touching things like the vise handle and such. Obviously, one of the critical components of manufacturing a titanium bike is keeping it very, very clean. So those dropouts are now on the holder very tight and ready to go into the fixture. So let's get put in place. I simply use a square to identify the rotation on those and lock them in place. Next, the head tube. Let's have a look-see. Just drops right onto the head tube puck. Align those vent holes. Pretty simple. Drop that holder down. Identify that it's good and straight in the jig. And it's good to go. And then the bottom bracket, got my own standoffs, caps, and a system for identifying the chainstay location here. And this bike is being built with a 87 millimeter raw length bottom bracket shell after facing it'll be a 86 millimeter shell width. So it's a T47, so a big oversized threaded shell. Also has the full internal hydraulic brake routing, so that's why the large vent holes and such. And I simply eye the position for the vent hole in line with the seat tube. Boom. We'll tighten that down. Good and tight. We've got our chainstay ready to go, flat mount brakes on there, internal hydro brake line in place. Simply slide that into place, and this is just a rough placement. I'll use a couple of tools to verify the final precise location of that chainstay just prior to tack welding. Drive side chainstay, same story. It'll get a final fitment before I actually perform any welding. And then next, seat tube. This bike is Di2 routing, so it has the port here for the Di2 wire for the front derailleur, ready to go. Still has some of the markings on the tube from Sandvik Special Metals. Just drop that into place. I use a rigid locator for seat tube position as well. Lock that guy down. Okay. Good to go. Seat stays. Double check them to be sure there's no water inside from the cleaning process. And place them as well. Now this is all probably looking pretty easy to you because this jig was already set because all these tubes were mitered to this fixture yesterday. So everything's set and ready to go, so they just drop right into place. Everything looks great. Coming together very smoothly. So again, gravel grinder, lots of clearance. This customer is looking for clearance for a 45 millimeter tire. And now all we have left is the down tube and top tube. Hydraulic brake routing and Di2 port. Just rolled a little bit under to the non-drive side to give the bike a really clean look. So that looks perfect. That's how we like it. And the top tube also, and I typically will knock it up a little higher than spec, and then use a C-clamp here so that it doesn't fall, and then identify my final position that I'm looking for, and bring that C-clamp up to just touch it, and it can hang out there until it's time to tack. Right about there. So I won't tack it as you see it here. I'll remove the down tube prior to tacking because we'll do the front of the seat tube before the down tube goes in. That way we don't leave any portion of that tube untacked. And then a final detail is the flat mount rear brake. It's important that that the positioning of that be very precise. My trick for that is to bolt in a parallel and then just prior to tack welding, utilize some other tools to verify that position. So, there you go. So now we're ready to put some argon gas in the tubes, get it flowing, seal everything off, and get tacking.